Previous video we discussed about the term frequency and we saw how term frequency is better than the simple frequency. Now we'll talk about the second part, which is IDF, inverse document frequency. Well, if you look at the formula of inverse document frequency, the formula goes like IDF is equal to the log base 2 total number of documents in the corpus divided by the number of documents with the term T. Okay, so there is some token for which you want to calculate the IDF. So you have to check how many documents have that token, and you have to divide that. Uh, you have to divide the total number of documents with that value, and the log base 2 of that entire, value. So how IDF is useful? So I'll explain that with a very simple example. Okay. So let's say there is a term. Let me minimize this a little bit. Let's say I have a small corpus where I would like to train a machine to move into different directions. So I will train the machine with various commands. For example, move left, move right, move forward, and okay, let me write it once again. Move left, move right, move forward, and move backward. Okay. So there are four documents: move left, move right, move forward, move back, move backward. And there can be similarly a lot of other commands which we can use to train a particular robot. Okay. Now, in these four documents, every document have a common word which is move, right? Every document they have a common word called move. Okay. Let's calculate the IDF for this particular token move. So as per the formula, the value will be log base 2. Okay. Uh, Total number of documents. How many documents we have? We have four documents divided by how many documents have the term T. That means how many documents have the term move. It seems like all four documents have the term move. So 4 divided by 4. So which is log base 2 of 1, which we all know that log 1 is 0. Okay, log 1 is 0. So what does that mean? What does that mean? That means IDF, inverse document frequency, tells us the importance of a token throughout the corpus. Okay, how much a token is important throughout the corpus. So it seems like move is a token which appears in all the documents. So it's a very common token. It is not at all important. Okay, it is a common token. It's not at all important. Let's calculate the IDF for this term left. So that will be log base 2. Total, how many documents we have? We have four documents, out of which left appears only in one document. So we have log base 2 of 4, and I have already calculated the answer for this, for that, which is 2. And hence, it proves that IDF, inverse document frequency, gives higher score to the rare words. Okay, it gives very high score to the rare and the important words, and it gives very less score to the repeating words or the very common words. Okay, so you can see that the move, which is highly repeating, has a score of 0, and the left, which is just there in one document, has a very high score of 2. Okay, and move has a very low score of 0. Okay, so we understood what is term frequency, we understood what is inverse document frequency, but how they work together, like the name of the uh, what do you call it, vectorizer. The name of the vectorizers is TF-IDF. So how they work together? Very simple. First of all, we calculate the term frequency for all the terms. So here, if you look into it, the term frequency for all the terms in each and every document will be 1 by 2, because each and every document has has a document length of 2, right? So, and it appears once, so 1 by 2, 1 by 2, which is ultimately what, 0.5, right? So the term frequency for every word is 0.5, and you multiply the term frequency by the IDF. So we know the IDF for move is 0, so 0 multiplied by 0.5, and the IDF for left is 0 is 2, which we have already calculated. So 2 into 0.5. Same thing will you'll do for all the other terms. So yeah, this is how the documents are converted into numbers using TF-IDF Vectorizer. It is slightly better compared to the count vectorizer, but definitely while performing the application, while writing the application, you should try both, and whichever gives you the better result, you should go with that one. Okay, guys, so we have completed the theory of both the vectorization. Now we'll go to the practical of text classification.